Example 5. Suppose we invest $100 in an account. Find the interest as a percent of the principal for each of the following interest rates. To save time, I used the compound interest formula to find the balance after 1 year. Then I subtracted the balance from 100 to find the interest earned after 1 year. So, according to the table, if the APR is 10% compounded annually, our $100 will earn $10 interest after 1 year. If the APR is 10% compounded semi-annually, our $100 will earn $10.25 after 1 year. And finally, if our APR is 10% compounded monthly, our $100 will earn $10.47 after 1 year. To find the interest as a percent of the principal for each of the following, we will take the interest earned after 1 year and divide it by the principal. We could then change the decimal into a percent to find the actual percentage return earned in a year. Here's our result. Notice when the APR was 10% compounded annually, our actual percentage return was also 10%. That is, our $100 principal increased by exactly 10%. When our APR was 10% compounded semi-annually, our actual percentage return after 1 year was 10.25%. That is, our $100 increased by 10.25% after 1 year. And finally, when our APR was 10% compounded monthly, our actual percentage return after 1 year was 10.47%. That is, our $100 increased by 10.47% after 1 year. The idea here is an APR of 10% compounded semi-annually is actually equivalent to a yearly interest rate of 10.25%. Similarly, an APR of 10% compounded monthly is actually equivalent to a yearly interest rate of approximately 10.47%. The annual percentage yield, or APY, is the actual percentage return earned in a year. The APY takes into account the effect of compound interest and gives a yearly interest rate equivalent to the APR. In the table above, the left column gives the APR, while the right column gives the equivalent APY. Occasionally, you may be given an interest rate in terms of APY instead of APR. You may use the APY instead of the APR in the compound interest formula given on the previous page as long as you change the compounding to annually. That is, we can calculate the balance after Y years as principal times 1 plus APY in decimal form to the Y power. Recall from our previous compound interest formula that our exponent represents the total number of periods. When we use APY instead of APR to calculate our balance, we are using an equivalent yearly interest rate, so a period is 1 year long. This means our exponent should be equal to the number of years our money is earning interest. Example 6. In March 2014, a bank offered a 5-year CD at 1.09% APY. If you buy a $100,000 CD, calculate the balance at maturity. Since we are given APY instead of APR, we will use the compound interest formula that uses APY. We get the balance after 5 years is equal to 100,000 times 1 plus 0.0109 to the fifth power. Notice we put APY in decimal form before putting it into our formula. Also notice we let y equal 5 since we wanted the balance after 5 years. To simplify, we combine 1 with 0.0109 to get 100,000 times 1.0109 to the fifth power. When I input this into my calculator, I get approximately $105,570.11. Once again, it's reasonable to round to the nearest penny because we are working with money. Financial institutions usually report their interest rates in terms of APR. But since the APY, or annual percentage yield, is the actual percentage return earned in a year, you should probably find out the APY before deciding on an investment. Here's a quick formula for the APY that you can use if you know the APR and the number of compounding periods in a year. APY equals the quantity 1 plus APR over n to the nth power minus 1. Here, both APR and APY are in decimal form, and n is the number of compounding periods per year. Example 7. Consider the two savings accounts described below. Which one pays us more money at the end of the year? The first savings account has an APR of 4.32% compounded quarterly, while the second has an APR of 4.27% compounded monthly. We know a higher APR means more interest, but we also know that compounding more often means more interest. Thus, it's not clear which of these two savings accounts will pay us more money at the end of the year. To help us determine this, we can use the formula above to convert from APR to APY, and in that way compare apples to apples. To find the APY of this first account, let's substitute 0.0432 into our formula for APR and 4 into our formula for n. We get APY equals the quantity 1 plus 0.0432 over 4 to the fourth power minus 1. Instead of trying to simplify this, I carefully input all of this into my calculator, including the parentheses and the exponent. Also, be careful that this minus 1 is not part of the exponent. Once inputted into my calculator, I get that the APY is approximately 0.0439 or 4.39%. Notice that the APY should always be greater than or equal to its equivalent APR, because the compounding associated with the APR makes the actual percentage return in a year or equal to the interest rate we use when we're doing our computation. When calculating the APY for the second savings account, we substitute 0.0427 into our formula for APR and 12 into our formula for n. We get APY equals the quantity 1 plus 0.0427 over 12 to the 12th power minus 1. Once again, be very careful when inputting this into your calculator. There must be parentheses around 1 plus 0.0427 over 12, and minus 1 cannot be part of the exponent. If you are having a difficult time using parentheses with your calculator, you can consider inputting this formula without parentheses but in multiple steps, determined by the order of operations. For example, you might input 1 plus 0.0427 over 12 first. After you find the answer to this part of the expression, you would take that answer to the 12th power. Then, after you find the answer to that part of the expression, you would subtract 1. If you choose to use multiple steps to perform this calculation, you must be careful to round as little as possible throughout the calculation. This may mean working with numbers with 10 or 12 decimal places. Even at the end of the calculation, if you want the APY accurate to 2 decimal places, you need to include 4 decimal places in your decimal answer so that when you change it to a percent, it will have 2 decimal places. After inputting this into my calculator, I get 0.0435 or 4.35%. Since we converted both APRs to APYs, we are now able to compare the actual percentage return at the end of the year. Since 4.39% is greater than 4.35%, the first savings account pays out more money at the end of the year. Note, if we were to have rounded to 1 decimal place as a percentage instead of to 2, the APYs would have been identical. Thus, for problems in which we are comparing close APYs, be sure to include enough decimal places so that you can determine which, if either, APY is higher.